Hey guys, welcome back to the channel. In the previous videos of this playlist, we have covered a lot of tokenization algorithms such as character, word, byte pair encoding, and WordPiece. And in this video, we will learn the final subword tokenization algorithm of this series, that is Unigram tokenization. So Unigram tokenization is a probabilistic subword tokenization algorithm which is commonly used in modern NLP systems through SentencePiece. The key idea that makes it different from BPE and WordPiece is that it starts with a very large vocabulary instead of a small one. And during training, it repeatedly removes tokens that contribute the least until it reaches the desired vocabulary size. So let's first understand the overall workflow. So we begin with a very large vocabulary containing many possible subwords. Next, we estimate how useful each token is by assigning it a probability. Based on these probabilities, we determine which tokens are important and which ones contribute very little. The least useful tokens are removed, and this process continues until we reach the target vocabulary size. So instead of building a vocabulary, Unigram gradually prunes it. So let's understand the working of this algorithm with the help of an example. So here we have taken a corpus where we have only 5 words with a frequency count given. So we initially start with a very large vocabulary where we consider all the possible subwords of a particular word, as you can see in the example. So now we calculate the probability or token-based probability of each of the tokens present in the subwords or in the words or in the corpus. So probabilities are basically calculated by the frequency of that particular token divided by total number of tokens present, frequency of all the tokens. So here we will see how we aim to find the best tokenization for a particular word. So this is done by comparing the probability of tokenization of the word in all different ways. So we take all the possible tokenization possible of a particular word with the help of the corpus and we find the probability of each one of them. And the one with the higher probability is the which is taken for consideration. So here just keep in mind that P, UG and PU, G have similarly high amount of probability. So this will be useful when we compute loss. So basically what exactly is loss? So loss is a metric which is needed for calculation of importance of a tokens. So the ones which have a lower loss after removal are the ones which don't really impact the vocabulary much and can be removed from the corpus. On the other hand, which have a higher loss, may have important information inside them and can't be essentially removed. So here we have considered the best tokenization of all the words present. So generally, as you know, probability is lesser than 1. So we consider when we multiply lesser than 1 probability 2 or 3 times, then the loss generally increases. So we, as you can see, in most of the cases we have a tokenization of 2 or 1 subword only. As the more number of subwords we tokenize it, the probability will be lesser. So now we understand the procedure of removing tokens. So you need to understand that, so suppose we temporarily remove the token PU, then we can observe that we can still tokenize the word pug into P, UG, and as P, UG and PU, G nearly had the same probability, there is almost no change in probability and in loss. So we can successfully remove it. And secondly, on the other hand, if we remove the tokenization hub, then we need to tokenize it in another way, that is HU, G, which has a lower probability than HUG. So which results in the increasing of loss, which is very significant. So we need to keep this word HUG. So one thing which you need to observe that is we don't always check all of the tokenization of words and then understand which one has the higher probability. We use an Viterbi algorithm, which is an algorithm which basically successfully guides the model to understand which of the tokenization has the higher probability. Another thing which you need to note is that we don't generally remove character-based tokens, as there might be cases where we aren't able to construct the word without these characters. So in conclusion, we can conclude that we remove the least important tokens. So here you can see at the entire training process. So we initially start with a very large vocabulary. We assign priority to each of the tokens. Then we tokenize the entire corpus in the best possible way via a Viterbi algorithm. Then we complete the corpus loss. Then we temporarily remove one token. Then we retokenize the corpus and measure the loss. If the loss increases, which means that the token was important and we can't remove it. And if it doesn't increase much, we can remove it, sorry. And in generally each run we remove about 10% of the vocabulary. And we keep on continuing this process until we reach our desired target vocabulary size. So that's going to be it for Unigram tokenization. And with this video, we have completed our tokenization series. So I hope you were able to learn a few things from this series. So if you want me to make a video or any other tokenization algorithm, let me know in the comments. And that's going to be it for the video. Make sure to like and subscribe and let me know in the comments how I can improve my videos in the future. Thank you guys.